This is Mr. G, and this is our warm-up for today's lesson. So pause the video right here, give these problems a shot, come back when you think you have your answers. We're going over 3, 2, 1, let's go. We're going to find the value of x that solves the equation. Let's take a look at number 1. We've got x times x plus 3 times x minus 2 equals 0. A lot of students, when they see this problem, they have the instinct to try and distribute. They're like, oh, okay, I know how to do this. I can just distribute, and that'll make things easier. Now, we are allowed to distribute here, but it's definitely not going to make things easier. It's going to make things a lot more difficult. And when you distribute here, we're going to get x times x, and then eventually distribute again. We're going to end up with an x to the third power. Now, we're still working on solving equations that have a highest power of 2, quadratic equations. So we certainly don't want to deal with any with a third power, if we don't have to at least. And we don't here, because this is just another example of the zero product property that we learned in our previous video. We've got 3 things this time being multiplied and they equal 0. Well, no matter how many things we're multiplying together, if the product of them is 0, then one of those things we're multiplying must equal 0. So the first thing, x, could equal 0. The second thing we're multiplying, the x plus 3, could equal 0. Or the last thing we're multiplying, x minus 2, that can equal 0. Move number 2 down here to get a little bit more space. And now we just solve our 3 equations. Well, x equals 0, that's already solved, so that's one answer. Take away 3. We get x equals negative 3. And add 2, and we get x equals 2. So those are the 3 answers to this equation. So distributing, trying to simplify these 3 polynomials, the 2 binomials and the 1 monomial, really would have made this more of a headache. Since it equals 0, just use the zero product property, set them all individually equals 0. Let's take a look at number 2. Now we've got a quadratic, x squared plus 49 equals 0. Now I don't see a b value. There's no x term. We just see an x squared. There's no x to the first power. That means we can just get x by itself here. Let's subtract 49 from both sides. That gives us x squared equals negative 49. The last thing to get rid of to get x by itself is that power of 2. We undo a power of 2 with a square root, because a square root and a squared undo one another. They're inverse operations. And we end up with x equals... Here's some answers I often get from students. Some students say, oh, it's going to be negative 7. But that doesn't work because negative 7 times negative 7, that's a positive 49, not a negative 49. And it obviously can't be plus 7 because positive 7 times positive 7, that's still a positive 49. So that's no good. In fact, if we think about it, there's no number we know that if we multiply it by itself, it gets us to a negative. I mean, negative 7 times a positive 7, that equals negative 49. But that's not a square root because that's not one number being multiplied by itself. That's 2 opposites being multiplied by them, or 2 opposites being multiplied. So the answer here is no real solutions. No real solutions. Not no solutions. No real solutions. Eventually, we will learn how to deal with numbers like this when we have a negative inside the square root. But right now, we're just going to put no real solutions. Once I write this so you can actually read it, that's a little bit better. All right, we're all done with our warm-up. Let's take a look at the objective. Today, we're doing Chapter 4, Section 7, and after today, we should be able to solve quadratic equations. Very similar to objective to our last video. We're solving quadratic equations. But before we jump into today's equations, there's a few topics we need to remember from algebra. So let's take a look here. It says simplify the square root of 9, the square root of 12, and the square root of 245. Now, if you have a calculator, that's going to make this a lot easier. Well, we don't need that for the first one. The square root of 9, that's just 3. That one was so easy because the 9 is a perfect square. But when we move down here to the square root of 12, all of a sudden it's not so easy because 12 is not a perfect square. Now, hopefully you remember from previous math classes, the way we get around this is, we could type it in and get a decimal, but if we want an exact answer, we don't want to have to round it. As soon as we round, the answer is no longer exact. So to get an exact answer, what we need to do, we need to rewrite our radicand, rewrite this 12. Remember, the word radicand means anything that's under a square root symbol, or really any radical. Where was I? We need to rewrite that 12 as something times something, where one of those numbers is a perfect square. So how can we rewrite 12 as something times something, where one of the numbers is a perfect square? We can take the square root. Well, hopefully you see, well, that's just 4 times 3. 4 times 3 is the exact same thing as 12. And now, all of a sudden, we can simplify this. Okay, so let's just, how do I want to do this? We could technically rewrite it like this as well, if that helps you. You don't need to do that step, but for some students that's helpful, so I'm going to show you that. Anytime you're multiplying two numbers inside a square root, you can split them up into two separate square roots that you're multiplying. And then that will become, well, the square root of 4, that's just 2, times the square root of 3 is just the square root of 3. We can't simplify that anymore because 3 is not a perfect square, and there's no perfect square factors of 3. So this would be a final exact answer for simplifying the square root of 12. It's 2 times the square root of 3. Let's do one more just to make sure we have this back in the front of our brains. We remember this from our previous math classes. Let's undo that. There we go. So we got the square root of 245. Now, this one, at least to me, is not as simple as the square root of 12. Like, as soon as I see that square root of 12, I go, oh, that's got a perfect square factor of 4. But with 245, that's, at least for me, it's more difficult to do in my head. So what I do is I just think, okay, I'm just going to try and divide 245 by a bunch of perfect squares. I like to start with the big one and sort of work my way down because we always want the biggest perfect square possible. Let's try, well, 100 is not going to work, obviously. Let's try 81. So 245 divided by 81, that gives me a decimal, so that's no good. So 81 is not a factor. What's the next lower one after 81? That'd be 64. Let's see, so 245 divided by 64. Another decimal, no good. Below 64 is 49. So 245 divided by 49, and we get 5. So that means we can rewrite the square root of 245 as the square root of 49 times the square root of 5. And then if you want to rewrite it as two separate radicals, you can. Or you can skip that step or skip straight to that step. It doesn't make a difference. Let me separate this work. And then the square root of 49, we know that's 7 times the square root of 5. And that's our final simplified exact answer for the square root of 245. Hopefully that sort of looked familiar or it makes sense at this point. Let's jump to the next thing we need to review. So we've got to simplify this expression 5x minus 2 equals 5. I want you to pause the video right here, give this problem a shot. We're going over 3, 2, 1, let's go. First, I'm going to show you the common mistake that students make. So don't feel bad if you made this, because a lot of students do this. I even made this mistake when I was a student. I just said, oh, x minus 2. This equals x minus 2 because we can cancel out those 5s. Man, that was easy and simple. But this is completely incorrect. These two things are not equal. Because, and how do I want to say this? The reason we can't just cancel out the 5s like that is because the 5x is not the only thing being divided by 5. The 5x is not the only number that's being divided by 5, or the only term that's being divided by 5. What I like to do with a problem like this, whenever we have sort of a polynomial, more than one term in the numerator, I like to do what I call distribute the division. I'm going to distribute the division. So, okay, this 5x, that's being divided by 5. Minus the 2, also being divided by 5. We take this 5 and we distribute the division. So every term in the numerator gets divided by 5. It's almost a shame that when we think of the distributive property, we immediately think of multiplying into parentheses, because this is just as much the distributive property, except instead of multiplying, we're dividing with it. And then let's see, now those 5s can cancel out, but not equals x minus, but the 2 over 5, that stays 2 over 5, 2/5. And that would be a simplified version of this expression. Now, if you made that mistake and just tried to cancel out the 5 and put x minus 2, don't feel bad, because students make that mistake all the time. I mean, I've even seen calculus students make that mistake just because it's so tempting. You're like, oh, this problem, when you're looking at it originally, you're like, oh, if those 5s could go away, that'd be so easy. It'd make my life so much simpler. But it's incorrect. So don't fall for that trap. All right. Now, let's get to our actual objective today. So we're solving quadratic equations. So remember, the first thing we have to do when we're solving a quadratic equation is figure, okay, is there a b value? If there's no b value, if b equals 0, then we can just do what we did in the warm-up and use square roots, get x by itself. But if b does not equal 0, if there is a b value, if there is an x to the first, like we see in this quadratic equation, then square roots aren't going to do it. Now, we already talked about how we can use factoring to solve it, but not every quadratic is factorable. There are plenty of quadratics out there that if you tried to factor them, you could not do it because they're just not factorable. That's where our second method, the quadratic formula, comes in. So let's talk about what the quadratic formula is, why it's useful, and sort of the pros and cons of it. So first, let me give you the notes to write down. So the quadratic formula, the first thing you always want to do is rewrite your rewrite your equation in standard form. So this should look pretty familiar. This is just going to tell you what A, B, and C are. And then you can plug that into the actual quadratic formula, which is right here. X equals negative B plus or minus the square root of B squared minus 4AC, all divided by 2A. This division is for everything, all right, not just what's under the square root, so be careful about that. Now, the advantage of the quadratic formula is that it always works. Whether the expression is factorable, whether it's not factorable, the quadratic formula will always work. The disadvantage is, I mean, look at it. It's hideous. It's just ugly. And if you're not really good at going through the order of operations quickly, it can take you a long time to simplify these. So usually what I do is if I have a quadratic equation, I'll try and factor it for maybe 30 seconds. And then if I still can't factor it in 30 seconds, I say, all right, I'll just use the quadratic formula. All right, let's jump into our example. So we got to solve the equation 3x squared plus 7x equals negative 2. Now, the very first thing we need to do here, well, we see there's a b, there's an x in the first term, so we can't just try and factor it. We can't use a square root. We can't get x by itself. So then our next instinct might be to try and factor it. Now, I'm going to spoil something here. This one is factorable, but I want to use the quadratic formula just so we can get some practice with that method. So let me rewrite this down here. 3x squared plus 7x equals negative 2. Hopefully we remember, just like factoring, the first thing we want to do, we want to get everything on one side of the equation. We want it in standard form. So I'm going to add 2 to both sides to get 3x squared plus 7x plus 2. We can't combine the 7 and the 2 because the 7 is a 7x. The 2 is a constant. It doesn't have any variables with it. Now we're ready for the quadratic formula. We see that A equals 3, B equals 7, and C equals 2. Hopefully you're good enough where you didn't have to write this down. I'm circling it like you can see it. Hopefully you don't need to write that down every time. I'm just showing my work. Now let's go straight to the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now I'm going to show every single step of my work here because this is the first one we're doing in this class. I don't want to say this. Eventually, to make this method actually useful, you want to be able to skip some steps. But right now, I'm going to show all my work. So let's see. B is 7, so it's negative 7, just substituting in, plus or minus the square root of b squared is 7 squared, minus 4 times a is 3, times c is 2, all divided by 2 times a, that's 2 times 3. So all we did there, we just substituted in, we plugged in A, B, and C. And now we're just going to simplify. We always start with anything that's grouped together with order of operations. So we're going to start with the radical. We're going to start with what's under the square root. So the negative 7 plus or minus just comes along for the ride, times the square root of, let's see, that's 49, minus 4 times 3 is 12, times 2 is 24, all divided by, we can do that 2 times 3, that's 6. Okay, now negative 7 plus or minus, there's still more to simplify inside the square root. 49 minus 24 is 25. That's all going to be divided by 6. Now let's see, we can rewrite that as negative 7 plus or minus. It's time to take the square root of that 25 and get 5, all divided by 6. And now here's where we need to split it up. We need to deal with this plus or minus. So I'm going to write it once over here. So x equals negative 7. I'm going to write it once with a plus, all divided by 6, and once with a minus. X equals negative 7 minus 5, all divided by 6. Then we just simplify. So let's see, negative 7 plus 5 is negative 2 over 6. That's negative 1/3. And down here, negative 7 minus 5 is negative 12, divided by 6. And we get negative 2. So those are our two answers. We got a negative 1/3 and a negative 2. Now, I said earlier that this example was actually factorable. The way we can know that at this point is if we get a perfect square. That's the final thing we need to take the square root of. If you get a perfect square there at the very end, then that means this was factorable. But it's like, okay, who cares? It took us a little bit longer than factoring, but we still got our answers. X equals negative 1/3, x equals negative 2. Let's do another one. We got to solve the equation x squared equals 22x plus 5. All right, first things first, we know we can't just get x by itself because we see unlike terms. We've got an x squared and an x to the first, so we need to get everything on one side. Now, we could subtract x squared from both sides. There's nothing wrong with that, but I don't like to have a negative a value. I like to have my a value, that lead coefficient, be positive, so I'm going to move everything else. I'm going to subtract 22x and subtract 5. Now you get the same answer if you do it the other way. This is I don't know, my OCD sort of kicks in when I see a negative in front. I want it to be positive. So we get x squared minus 22x minus 5 equals 0. Now we're ready for the quadratic formula. We can see that a equals 1, b equals negative 22, and c equals negative 5. If you don't need to write down that step, that's a good thing. I'm just showing all my work. Now let's write down the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now we substitute in. Now, like I said, eventually you're going to want to get to the point where you can skip some of these steps. I'm going to show all my work though, because I don't want to confuse anyone. Let me see. It's negative b, and b is a negative 22. So minus a negative becomes positive. Anytime you have minus and then a negative, they cancel each other out, and we get a positive 22 to start off. Then plus or minus the square root of b squared, that's negative 22 squared, minus 4 times 1 times negative 5, all divided by 2a. That's going to be 2 times 1. Well, that's just 2, but we'll fix that on the next step. All right, now we start simplifying inside the square root. The 22 in front just comes along to the right. Let's see, square root of, well, negative 22 times negative 22. It's going to be positive something, 484. Positive 484. Then let's see, negative 4 times 1 times negative 5. That's going to be positive 20, all divided by 2. Then we simplify them some more and get 22 plus or minus the square root of 504, all divided by 2. Now at this point, this is where our roads sort of diverge. We see we have a non-perfect square, which means we can't easily take the square root of it, which means, okay, this was not factorable. The quadratic formula was the right strategy to use here. We're going to write an answer two different ways. We're going to write it as an exact answer and as a decimal approximation. First, let's talk about how to get to the exact answer. To get to the exact answer, we need to simplify this radical. So we'll erase this in a second. I'm just going to show my work here. We got to find a perfect square that is a factor of 504. 100's not going to do it. Let's see. After 100, we can divide by 81. That's a decimal. Then 504 divided by, what's after 81? 64. Still a decimal. 504 divided by 49. Still a decimal. 504 divided by 36. And we get 36 times 14. So 36 and 14 are the two factors we can use to simplify the square root of 504. So let me move this over real quick. Like I said, we'll erase that once I actually use it. So it becomes 22 plus or minus the square root of 36 times the square root of 14, all divided by 2. We don't need this anymore. What we can do now is get 22 plus or minus. We can take the square root of 36 and make it 6 times the square root of 14, all divided by 2. Now, the very last thing we're going to do to get our exact answer is we're going to distribute the division. We're going to take this divide by 2 and distribute it to both of our terms. So the first thing that's going to happen is 22 divided by 2, that becomes 11, plus or minus 6 divided by 2 becomes 3, and the square root of 14 just comes along to the right. We can't divide the square root of 14 by 2 because the 14 is inside of square root, the 2 is not. So we have to keep them separate. But we can do 6 divided by 2 because they're both outside the square root. And this is one way we can leave our answer. That's the exact answer, x plus or minus 3 times the square root of 14. But what if we wanted to get a decimal approximation? Well, that's where a calculator comes in. It'd be 11 times, let's see, what's 3 times the square root of 14? That became 11.22. We'll round it to the nearest hundredths place, the second decimal place. And then we can just write that. So the first way would be we add together. So 11, well, we don't need a calculator for that. 11 plus 11.22 is 22.22. That's kind of weird. Yeah, that's what it comes out to. And then the second answer would be approximately 11 minus that would be negative 0.22, if I'm doing that correctly in my head. So those are two ways to write our answer, as a exact answer and as a decimal approximation. All right, just two more to go. We got to solve the equation 6 equals x times x plus 2. First, I'm going to write it. 6 equals x times x plus 2. Now, right away, I'm a little bit more worried about this one because, like, all right, we've got an x times an x plus 2. We've got a monomial times a binomial. Now, if you're thinking from the warm-up, oh, I remember what we did in the warm-up. We set each of them equal to what was on the other side. So we can do 6 equals x and 6 equals x plus 2. But we can't do that. We can't do that because this number right there is not a 0. We can only split it up like that if it's the 0 product property. It's not the 6 product property, okay? So we can't use that trick here. Here, we have to distribute. 6 equals x times x is x squared, plus x times 2 is 2x. And then let's see, let's get everything on one side, so we take away 6 from both sides. It's 0 equals x squared plus 2x minus 6. And now we can use our quadratic formula. I don't think this is going to be factorable. Yeah, let's just go straight to the quadratic formula. So we know a equals 1, b equals 2, c equals negative 6. And we're going to write out the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now I'm going to show you how you can make this a little bit faster by skipping some steps. So the first thing we're going to do is we're going to start simplifying as soon as we're substituting in. So negative b becomes negative 2, plus or minus, here's where we're going to start skipping some steps. So it's b squared. Well, we can do that in our head. b is 2, so 2 squared becomes 4. Then it's going to be negative 4 times a times c. So it's negative 4 times positive 1 times negative 6. The first thing I worry about is the sign. Negative times negative will make it a positive. Then it's just 4 times 1 is 4. 4 times 6 is 24. All divided by 2a. That's 2 times 1, so I'm just going to write 2. So just by skipping some steps as you're simplifying, you can make these a lot faster, or skipping some steps as you're substituting. Let's see what we can do next. So x equals negative 2 plus or minus the square root of 28, all divided by 2. Let's try and simplify that square root of 28. It's not a perfect square. I can divide it by 4, though. So that'd be negative 2 plus or minus the square root of 4 times the square root of 7. And that's all divided by 2. And let's see, negative 2 comes over, plus or minus the square root of 4 is just 2. Square root of 7 comes along for the ride, all divided by 2. All right, just one step away from getting our exact answer. We just take the 2 down here and distribute the division. So negative 2 divided by 2 is negative 1. Plus or minus 2 divided by 2 is just 1. So it's just 1 times the square root of 7, or just the square root of 7. So that's our exact answer in simplest form. Now if we want a decimal approximation, let's see, that'd be negative 1 plus or minus the square root of 7. Just estimate that in a calculator. That's 2.65, we'll round it to 2.65. And now we just do it once with addition, once with subtraction. So let's see, when we add them together, it's going to be 1.65. When we subtract them, that's going to be negative 3.65. As long as I did that correctly. Let me double check myself. Yep, looks good. There we go. We got answers in exact form and rounded to the nearest hundredth place, the nearest second decimal. All right, last one. I want you to try this one on your own. Solve the equation 4x times x minus 3 equals negative 10. We're going over 3, 2, 1, let's go. I'm going to rewrite this here just so I have a little bit more space for my work. And then we distribute to simplify because we can't split it up because it doesn't equal 0. We have to distribute. There's no shortcut here. So 4x times x is 4x squared. 4x times negative 3 is negative 12x equals negative 10. Then we can add 10 on both sides and get 4x squared minus 12x plus 10 equals 0. Let's see. Now here, we actually could factor out a GCF, like divide each of these by 2. We don't have to do that, though. It doesn't really make a difference. It'll make the numbers a little easier to deal with, but I think we can handle it. I'm just going to go straight to the quadratic formula. So that's going to be x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's see what happens. So negative b is positive 12, plus or minus the square root b squared. It's negative 12 times negative 12. That's positive 144. Let's see. It's going to be a minus. It's negative 4 times 4 times 10, so that's negative 16 and negative 160, all divided by 2a, that's going to be 2 times 4, that's 8. But if you were thinking ahead, you would see, oh, we don't even care what this 8 is. As long as it's not a 0, and it won't be if it's quadratic, as long as that's not a 0, we don't even need to move any further. As soon as you saw this, you should have thought, oh, I know what the answer is going to be. Because that's going to be a negative number. 144 minus 160 is a negative number. When we try to get the square root of a negative, we get no real solutions. So we don't need to go any further. That's our answer. So always be on the lookout for that. Sometimes you get no real solutions. And I personally actually like them better because we get to stop early. There's less work to do. Here's your homework. I want you to do page 245, numbers 11, 14, 17, and 20. Hopefully this all makes sense. As always, if you have questions, reach out to me. Enjoy the rest of your day.